Okay, so we're continuing with EPI exercises, and today we're going to do exercise 4.6, I believe. Yes, it's 4.6. Compute quotient. Okay, so compute quotient. In this exercise, we need to implement our own divide function, and we can only use addition, subtraction, and the shifting operators, both right and left. Cool. Yeah, so one way of doing this, let's say that we have an example, so 15 divided by 3, which is 5, right? So we cannot use this divide, we have to implement our own. So one way of doing this would be just to reduce 3 from 15 and have a counter here, right? Until 15 is less than 3, right? So we have 0, and then our result would be 5, right? We can also just optimize this by using shifting to do more work, right? So, but the time space complexity for time will still be, so time will still be of n is number of bits, and for space, space is of 1 because we won't be using any additional space here. So let's just quickly implement this optimized solution. So we have divide function. So we have x and y. Cool. We'll be initializing our results variable and power. So results will be initialized to 0 and power to 32, right? And we have power because we will be having y power, and from the name you can see that we just basically we have y value, and we're left shifting by 32, right? And we will be having while loop, while x is greater than or equal to y. So if y is bigger than x, it should be 0, which it is, results at 0. So once we're in here, we can say while y power is bigger than x, we will be reducing or shifting y power until y power is not bigger than y, right? So y power, shift this guy by 1, and of course we need to reduce power by 1. Once we're out of this loop, we can update our results variable. So results is actually whatever we have in power, and because we're calculating this here, we need to remove y power from the x, right? So the x will be reduced by y power, right? And once we're done, we can just return results, right? Okay. So yeah, let's quickly implement this in code. So we have our results and power variable. Results is initialized to 0 and power to 32. To the power, while x is greater than equal to y. Y power will be shifted by 1, and then power is reduced. And once we're out of this loop, right? Out of this loop, oops, this guy. We can just update results, the current power, and we need to reduce x by y power. Cool, let's look if this looks good. So we have results and power. Okay, and we're updating here. Okay, it looks good. And a test pass. So that's it for this one, and see you guys in the next one. Bye.